Alright, SL11 students, it's time for one of my favorite things in math. Really, it's one of my favorite words. What we're getting ready to do in section 4.4 is we're going to look at properties of logarithms. Absolutely love that word logarithm. Alright? And they're actually pretty fun to evaluate as well, and I think you're going to see that in this video. As you understand the process, it'll be good. Now, our goal, as you can see in this lesson, is that you're going to learn to use properties of logarithms to evaluate logarithmic expressions. Alright, it should be familiar to you from Algebra 2, so this really will be a bit of a review, but we're going to talk about several properties of logarithms and how you evaluate logarithms with those properties. Very simple. Alright, let's go ahead and take a look at some of these. What I'd like to do first is describe to you what a logarithm is. And so we're going to look at the expression log base a of b, or the logarithm base a of b. And that is the way that you read it, is log base a of b. And I want you to know what it is that you're being asked for when you're given a logarithm and you're trying to evaluate. Okay? Now, I've got two columns here, and I'm going to write a logarithm in one column and the exponential form of that logarithm in the other one, because logarithms, it turns out, really are exponents. A logarithm is an exponent. Alright, and I'll start off with the most basic one. If I ask you what log base a of b is, well, that's the same thing as asking what power of a is equal to b. Make some sense? Let me do that with some specific numbers. Let's say I asked you what log base 5 of 25 is. What that means is what power of 5 gives me 25. Alright? And you ought to recognize that would give you 2, so that's what log base 5 of 25 is. Alright? Or let's say that I was to give you an equation in exponential form, such as 7 to the x power equals 343. Well, another way of writing an expression that would figure out what that exponent is log base 7 of 343. Each of those is asking what power of 7 gives you 343. And so, and in both instances, you'd end up getting 3. 3 is the exponent of 7 that gives you 343, so that's log base 7 of 343. Very simple, right? All right, we're going to kind of go rapid fire through many logarithms. I got a whole lot of them in this example. And as we go through them, I'm going to try to illustrate the various properties that you need to be familiar with. All right, so let's take a look at the next one. All right, what I'd like you to do here is simply evaluate these expressions, which will be logarithmic expressions. And we're going to start with log base 4 of 64, work our way down to log base 7 of 1 over 49, and so forth. You can read the examples. I don't have to read them for you. But in each one of these, we're wanting to know what power of the indicated base will give you the number that you're taking the logarithm of. All right, one note that I want to make really quick right now, mostly because I forgot to use it in the previous slide. If you're looking at log base a of b, a has to be greater than 0. Alright, for log base a of b, a has to be greater than 0. The base always has to be a positive number, in other words. Alright, log base 4 of 64. Well, what power of 4 gives you 64? Well, going to be 3, isn't it? Maybe this gets a little bit tougher right here, and so I'm going to approach this a slightly different way. Now with log base 7 of 1 over 49, I want to know what power of 7 gives you 1 over 49. Well, I hope you recognize that that's the same thing as this. So log base 7 of 7 to the negative second power, right? And if I want to know what power of 7 gives me 7 to the negative second power, I hope it's fairly obvious that that's negative 2. Alright, log base 10 of the square root of 10. Well, we just got done learning that the square root of a number is the same thing as raising that number to the 1/2 power. So when I ask for log base 10 of the square root of 10, that's really asking what power of 10 gives me 10 to the 1/2 power. And within that question is really the answer, isn't it? 1/2 would be the value of that logarithm. Hope you're getting the hang of it. Now with these last two examples here, I just illustrated a certain property that I want you to make note of. Alright, you can see from here and here that if you ever have log base A of A to the nth power, that gives you n, because what power of A gives you A to the nth power? Well, obviously n is kind of the answer to that. Great, let's go through some more logarithms. 3 more for you to try here. And I would like you to try these really quickly, and then we'll come back and talk about them. Hopefully you'll notice a pattern with the first two and a pattern with the second two of these. Go for it. Alright, for the first pair of logarithms that I gave you on this slide, I'm asking what power of 12 gives you 1, basically, and that's 0. Then I asked you what power of the number e gives you 1. Well, that's also 0, because isn't any number to the 0 power equal to 1? Alright, and so based off of that, we've got a property. If you're ever asked to find the log base A of 1, it doesn't matter what the base is, that's always going to be 0, because A to the 0 power is equal to 1. Alright, log base A of 1 always equal to 0. Now a similar pattern occurred with the bottom two logarithms. In part F, I want to know what power of 6 would give you 6. Well, that's 1. Log base 6 of 6 is 1. What power of 21 will give you 21? Well, that's the first power, because any number to the first power gives you that same number, right? So another property for logarithms, and I hope that you're writing down all these properties, is that if you ever take the logarithm base A of A, it's always going to be equal to 1. Alright, let's move on. This time we're going to try to take the logarithms of negative numbers and of 0. Alright, I want to let you think about this for a moment. Pause, see what you come up with. It's kind of tricky trying to figure out what power of 3 would give you a negative number, isn't it? And there's a good reason for that. 3 to the first power is positive. 3 to the second power is positive. 3 to the third and fourth and fifth power are all positive, aren't they? And in fact, 3 to any power is guaranteed to be a positive number. I'll write that over here. And this isn't just true for 3, it's true for any number. Alright, so that's for all values of x. And what I'm trying to tell you is when you're trying to find log base 3 of negative 3, there is no power of 3 that gives you negative 3. So that logarithm is undefined. And in fact, the logarithm of any negative number is guaranteed to be undefined. Remember, we don't allow negative bases, so there's never an instance where we're going to have a logarithm that's going to give you a negative value. Well, I misspoke there. You're never going to be able to take the logarithm of a negative number. Alright, so let me write down the property kind of associated with that. And that property is this, that log base A of B is undefined if B is less than 0. Alright, and what you come up with for J and K? Well, turns out if you take a power of 5, you're always going to get a positive value, aren't you? It's not going to give you 0 ever. Whatever power you raise 2 to is going to be positive as well. It's impossible to get 0 by raising a number to a power. And so these bottom two expressions are undefined as well. And because the logarithm of 0 is undefined, I can amend that property that I just wrote a moment ago. When I said log base A of B is undefined if B is less than 0, turns out log base A of B is undefined if B is less than or equal to 0. You can't take the logarithm of 0, cannot take the logarithm of a negative number. Excellent. We've got one more slide to go through here. Let's try it out. 2 more examples, and these are tougher examples that are possible to find the value of, though. Alright, the last ones were undefined. These are not undefined whatsoever, but they're not so obvious at first. Alright, now looking at log base 4 of 8. If I'm just thinking about powers of 4, which I'm going to list at the bottom, you don't need to copy these down. Powers of 4, well, 4 to the 0 power is going to be 1. 4 to the first power is 4. 4 to the second power is 16. We skipped right over 8, didn't we, when we were listing our powers of 4? Well, that means 4 to the x power, well, what power of 4 gives you 8 has to be between 1 and 2. Hopefully that makes some sense. My point is this, though. If you ever have a logarithm that's tough to evaluate at first, what we can do is we can use the fact that we know how to change these expressions from logarithmic form into exponential form to our advantage. What I'm going to do is, instead of writing that as log base 4 of 8, I'm going to write an exponential equation. I'm going to say what power 4 is equal to 8. How in the world does that help? Well, remember we learned how to solve an exponential equation as long as you can write both sides of the equation as powers of the same base. And isn't 4 a power of 2? And then isn't 8 of a power of 2? So this tells me that 2 squared to the x power equals 2 cubed. And so then you end up with 2x equals 3, x equals 3 halves. Alright, try that same thing for this last example here. I want you to rewrite this logarithm expression in exponential form as I did right there. And then I want you to write both sides of the equation as powers of the same base so that you can find out what the value of that logarithm is. Alright, so there's our exponential equation. We're asking what power of 27 gives you 9, so we can say that's 27 to the x power equals 9. 27 and 9 were each powers of 3. 27 is 3 cubed, so we can write that as 3 cubed to the x power. 9 is 3 squared. Alright, so we've got the same bases now on either side, so we can set the exponents equal to one another. Whoops. So 3x equals 2 means x is equal to 2/3. Alright, last thing I'll do with these, really there was no x in these expressions that I was trying to evaluate, so I'm going to write my answer a little bit differently than what I did right there. We'll just say that log base 4 of 8 equals 3 halves, and that log base 27 of 9 is equal to 2/3. That's how you evaluate logarithms. Hope you paid careful attention to all the properties that I mentioned and how to change from exponential form to logarithmic form and all of that. Very simple. I'll see you next time.